What if you could glimpse the future of air combat? The future is now. The secret American fighter jets and aerial weapons of tomorrow are being developed today. Incredibly powerful engines push fighters to the edge of space. Sophisticated helmet systems give pilots a 360-degree view of the battlefield. And stealth. Invisible planes that can strike anywhere in the world at a moment's notice. But with every advance, the enemy will be sure to counter, even striking in space itself. This isn't science fiction, but actual scenarios based on known diagnostics. A glimpse of what's coming very soon. Experience what will be. Dissect the tactics. Witness the awesome spectacle of the dogfights of the future. June 20th, 2016. A United States Coast Guard air rescue helicopter races into hostile territory. America's military is on high alert. A civilian aircraft has been shot down by a foreign power, and a rescue effort must be mounted. To provide air cover, the Air Force scrambles a flight of 4 aircraft. F-22 Raptors, the most formidable fighter aircraft ever constructed. The Raptors, stealth fighters, streak into the danger zone at over 1,000 miles per hour, Mach 1.5. They are virtually invisible to enemy radar. The F-22 is just one of a lethal new breed of fighting machine that even now are redefining aerial warfare.
Quantity is a quality all of its own, and the Western world is very much putting its eggs in the basket of high technology, fewer numbers that can achieve the same effects on the target because you have precision and stealth.
These amazing machines are the culmination of a century of fighter aircraft development. The first combat aircraft, or so-called Generation 1 fighters, took to the skies in World War I. Planes like the Fokker D-7, SPAD-13, pioneered fighter aviation, topping out at just over 100 miles per hour. Generation 1 reaches its apex in World War II. Planes like the P-51 Mustang and German Bf-109 could fly and fight at well over 400 miles per hour. But by the close of that war, the first Generation 2 fighters, jets, upped the ante. One of these, the German Me-262, could fly over 500 miles per hour. After the war, the United States and Soviet Union developed their own Generation 2 aircraft, like the F-86 and the MiG-15. They pushed over 600 miles per hour, near the sound barrier, in clashes over Korea. Lessons learned in the Korean conflict, coupled with far more advanced electronics, spurred a leap in speed and killing power for Generation 3 aircraft, like the F-4 Phantom and Soviet MiG-21. They topped out at over twice the speed of sound, some 1,400 miles per hour.
Third Gen began to introduce avionics types of engagements, radar-guided missiles, and the air-to-air engagement.
By the early 1970s, Generation 4 fighters like the American F-14 and F-15 were deployed. These aircraft featured far more sophisticated avionics. The electronics suite that supports navigation, radar, and weapons.
In developing the Gen 4 fighters, not only did they have a whole lot more computer power to work with, but it was a mindset change to create the ultimate killing machine.
But no matter how fast or well armed, The advance of ground radar and surface-to-air missiles during the 1970s and 80s meant that entire sections of sky could be denied to even the finest Generation 4 aircraft.
The life expectancy for a Gen 4 fighter over anywhere that we may go in the near future is very little. And I'd say easily 50% loss is only because the enemy is not going to have enough missiles to shoot these guys down.
To survive and dominate this environment, radical new technologies are needed. Enter the F-22, the world's first Generation 5 fighter. First proposed in the 1980s, the F-22 is a single-seat fighter. It was unveiled to the public in 1997 and delivered to the Air Force in 2003. Its true top speed, a closely guarded secret, is well over 1,400 miles per hour. It is armed to the teeth with 6 radar-guided missiles and 2 heat seekers.
The F-22 Raptor, I saw that first at Andrews back in '91. If Kim Basinger was an airplane, that's the one she'd be. Just a startlingly beautiful aircraft. It outperforms the F-15 heavy regime when it's invisible to radar. It don't get much better than that.
Initially, when the jet was conceptually designed, it was always meant to be an air-to-air fighter, because it was supposed to replace the F-15C, and that jet's main role and mission in the Air Force was an air superiority platform.
Now, a flight of F-22s will employ a startling array of high technology in a hypothetical future combat scenario. 4 Raptors race to provide cover for an air rescue unit. The Raptors speed in with aid of an advanced engine capable of super cruise, a revolutionary technology introduced in the F-22 that allows it to fly extremely fast while conserving fuel. Super Cruise utilizes a powerful Pratt & Whitney F-119 PW100 engine and sleek aerodynamics to allow the F-22 to fly faster than the speed of sound for long periods of time without aid of an afterburner.
I can cover a whole lot more territory at Mach 1.5 than I can cover at 0.9 Mach. When I don't have to use afterburner to achieve that altitude and that airspeed, it allows me to stay up there longer, so I'm not wasting all my gas and I have a little bit more endurance.
The Raptors arrive on station just as the Coast Guard begins the rescue. Then, the Raptors detect a formation of 14 enemy MiG-29s on radar. Suddenly, with no warning, the MiG-29s fire on the rescue helicopter. As the rescue helicopter's frantic radio calls fall silent, a stark realization sets in. The F-22 Raptor is now in a shooting war. They are outnumbered 3-1. It's time to prove that the Raptor's technology really will make up for numbers. Their primary advantage, and the cornerstone of Generation 5 technology, is stealth.
People don't understand how diabolical stealth is. A stealth aircraft is not completely invisible to radar, but if you track an aircraft, it means you have to track every sparrow and dragonfly in the sky.
Stealth is not only the shaping of the airframe, but the materials used in the airframe for the sole purpose of not reflecting radar pulses back to the bad guy's radar. That first came into what we call an attack airplane as opposed to a pure fighter in the F-117 Nighthawk.
The F-117 uses a uniquely shaped airframe to scatter radar energy. The odd angles made it unstable in flight, and the radar-absorbent coating was expensive to maintain. This early type of stealth could not be used in an air superiority fighter like the F-22. So engineers developed an improved form of stealth called planform alignment. Planform alignment orients flight surfaces and small structures on the aircraft at the same angle. The result is something like a camera lens that shapes and focuses radar energy and directs it away from the detecting station. This allowed engineers to design a much smoother, more aerodynamic shape for the F-22, making it stronger, faster, and more maneuverable than the F-117.
In this modern era of stealth combat, there are two types of fighters: stealth fighters and targets.
Now, witness how stealth will change the future of aerial warfare as a single flight of 4 Raptors engages a formation of 14 MiG-29s. The F-22s are invisible to the enemy. They can pick where and when to begin the fight.
Any other 4th generation fighter aircraft in the world, for the most part, what they're going to see when they're being targeted by a flight of Raptors is nothing.
The Raptors obtain lock and fire. The missiles deploy from internal weapons bays. If the missiles were mounted externally, the F-22's stealth outline would be broken. Warnings blare in the MiG-29 cockpits.
The bad guys won't know they're in a fight until the airplanes start blowing up, which is kind of a tough way to learn that lesson.
Still undetected, the Raptors fire another volley of advanced medium-range air-to-air missiles, or AMRAAMs. These AMRAAMs are AIM-120Ds, top speed over 2,000 miles per hour. They could be on operational U.S. fighters sometime after 2010. The D possesses better range and guidance than the AIM-120C in use today. Both are so-called fire-and-forget missiles. Once it is halfway to the target, the missile's onboard radar takes over to guide the 45-pound high-explosive warhead to impact.
So what that basically allows us the capability to do is designate a target, and once its own radar acquires a target, then it allows us in the cockpit to basically forget about that missile.
The MiG-29s take evasive action, deploying chaff to confuse the missile's homing radar. Some manage to cheat death, but in the end, 8 are destroyed or damaged. The rest retreat to friendly airspace. The engagement typifies the strengths of the F-22 in a dogfight of the future.
What does 5th generation give you, 4th generation doesn't? You'll know where the other guy is. You'll know what he can do. You'll know he can't reach you and you can reach him. You'll always engage from an advantage, and the advantage is tremendous.
But just as the Americans believe the fight is won, an ominous signature appears on long-range radar. Nearly 150 miles to the east, an even larger enemy force of 24 Su-30 MKI flankers and Mirage Rafales race to the aid of the MiG-29s. The F-22s are outnumbered.
In the F-22, we routinely train to fighting outnumbered. We realize that if we only have a certain number of operational squadrons of F-22s, we're going to have to do a whole lot with not very much.
The F-22s move to engage the enemy force. Their only hope of surviving against these overwhelming numbers will be a secret future weapon, one few today have heard of, capable of astounding destruction. June 20th, 2016. In a hypothetical combat scenario, based on what we now know of future aerial warfare, a flight of F-22 Raptors engages a large formation of 24 Su-30 MKI flankers and Mirage Rafale fighters. Aircraft like the Russian-built Su-30 and French-built Rafale are widely exported and easily obtained by nations looking to build an air force quickly. They are advanced Generation 4 fighters, the most likely opponents for the F-22 in the next decade. The Raptors are heavily outnumbered, but virtually invisible to radar, and at a safe distance of 80 miles away. As they sort through incoming data and develop a plan, they are aided by the F-22's sensor fusion, or integrated avionics, a technology that no other fighter possesses. Previous generations of fighters, like the F-15, separated avionics into individual systems, requiring the pilot to interface with several different panels spread throughout the cockpit. But the F-22 integrates all of these systems into one unified interface, all at the pilot's fingertips via 3 liquid crystal displays in the cockpit.
What pilots don't lack for is data. What they need is information. And sensor fusion gives them information instead of just lots of data from different sensors.
With this, the pilot spends less time monitoring basic systems and more time making combat decisions.
It creates an outstanding situational awareness picture for the pilot. You see the bad guy farther away, he doesn't see you. And then you get the first look, first shot, first kill. And the more of those that you can do before he even knows you're in the area, the war can be over very quickly.
Between them, the F-22s only have 12 missiles left. They'll need more firepower to engage the huge enemy formation in front of them. They enlist the help of a pair of nearby B-1Rs. The B-1R, first outlined by Boeing in 2004, is a proposed replacement for the venerable B-1B Lancer, a supersonic strategic bomber in service since 1986. The B-1R has a top speed of Mach 2.2, twice that of other heavy bombers like the B-52. If built, it would be equipped with the same powerful engines the F-22 uses, the Pratt & Whitney F-119. This means the B-1R will have supercruise, just like the Raptor. Add advanced radar and a full complement of 20 AIM-120D missiles to the mix, and it is clear how formidable this future weapon could be.
Let's say we have a Raptor that's able to detect, localize, and fix an enemy aircraft. Transmit that information back to a command and control circuit or to the bomb truck or the missile truck itself. And then have the missile truck fire the missile against the enemy. The large aircraft, like a B-1, can carry so many missiles that it doesn't really impact when one is fired. And they can also afford to fire 2 or to ripple missiles if they need to.
This sort of highly technological teamwork between multiple air assets is another key aspect of how a future air war will be waged. Before the B-1R attack, the stealthy Raptors will engage the enemy formation by firing their remaining radar-guided missiles. Not enough to take out the whole formation, but enough to sow confusion and panic. They hope this will protect the unstealthy B-1Rs from counterattack. The Raptors move in. A complete radar portrait of the enemy force is drawn from sensors all over the F-22. Even the skin of the plane itself is a sensor, called the Distributed Aperture System.
What that is on each of the aircraft's skin, along the wings, there's thousands of tiny little receivers, passive receivers, that can take in signals intelligence. These are very good for missile warning. They give you a very good idea of what's coming at you.
The F-22s fire their remaining AMRAAMs. All that's left in their weapons bays are close-range, heat-seeking missiles. The volley tracks the enemy formation, boring in on their mark at over 2,400 miles per hour. At this speed, it takes just 7 seconds for the missiles to cover the final 5 miles to the target.
All of a sudden, the bad guy's flight starts falling apart. Everybody's scrambling, try to get away from the missiles. Chaff, flares, whatever it takes.
Then, the Americans complete their 1-2 punch. Like a team of Special Forces soldiers deep in enemy territory, the F-22s, still undetected, relay targeting coordinates to the B-1Rs via a secure broadband data link. They ripple fire missile after missile from the AMRAAM's maximum effective range of 120 miles. It's a 21st century version of the Archer's fusillade in medieval combat. Missile warning radar in the enemy cockpits once again raises the alarm, but to no avail. The enemy is too disorganized from the Raptor attack to effectively counter. The chaos among the enemy ranks perfectly illustrates the stunning advantage of high technology in a dogfight of the future.
Can you imagine what that would do to a command and control cycle when all of a sudden your aircraft are disappearing from missile shots and you have no idea where the targeting is coming from?
In just a few moments, it's every man for himself. Radio chatter is intense as the enemy tries to determine who is alive and who is dead. But among the confused and scattered formation, a handful of pilots flying French Rafales managed to survive the storm of AMRAAMs from the B-1Rs. Here's how.
In order to defeat a missile that's been launched on you, first of all, you got to know it's coming. So you've got to have a good radar warning system that's going to let you know, A, you're locked on, and B, there's been missile launch at you.
The AMRAAMs fired by the B-1R use Doppler shift in the radar returns to calculate path of travel, speed, and distance to a target. For the Rafales, survival depends on understanding this and knowing how to overload the missile's tracking system. The enemy pilots survived by breaking into the AMRAAM, perpendicular to the missile's flight path. Then they released chaff, strips of aluminum that reflect radar energy.
If you go past 90, 110, 120 degrees and dive for the deck, there is not a missile that is going to be able to track you down.
The 6 remaining Rafale fighters now move against the distant B-1Rs, the only target their radars can find. A volley of missiles roar past Mach 3 in pursuit of the B-1s. This moment in the dogfight demonstrates just how vulnerable an unstealthy Generation 4 aircraft will be in a future air war. The aircraft is damaged, but not knocked out. The B-1 pilots go full throttle, with a top speed over Mach 2. They're fast, but not fast enough to outrun a Rafale in full afterburner. Their hopes rest on the dogfighting prowess of the F-22s, who move in to engage the enemy within visual range. This battle will be decided up close and personal, with the F-22s in full sight of the enemy. It is the year 2016. In a hypothetical scenario, 2 American B-1Rs were just attacked by enemy Rafales. Now it's up to a flight of F-22 Raptors to intercept the Rafales before the B-1s are lost. It's 4 F-22s versus 6 Rafales. The Dassault Rafale, with a top speed of Mach 2, is a formidable foe. Though it is not stealth, the Rafale possesses a reduced radar cross-section, the details of which remain classified. With no long-range missiles left, the Raptors will be forced to move within visual range. It's a scenario that has been repeatedly declared extinct.
Especially when you talk to the defense contractors today, because they are always talking about the importance of sensors and systems and avionics and how we've really gotten beyond the dogfight. And it's always turned out that we do get back into these close-in conflicts where you're going to be eye to eye with the opponent.
It's not going to change. I mean, the line of sight can be at 500 miles or it can be 100 yards, depending on the circumstances of the engagement. The other guy can just get lucky and get in close, in which case the F-22 Raptors have to show how well it can maneuver.
The Raptors assign targets.
I'm going to go to the merge and I'm going to get the job done. Now, like I said, if I can't shoot BVR, then I've got to go within visual range to get the job done.
In seconds, one of the Raptor pilots spots a glint of metal on the horizon. The Rafale breaks into him. Within visual range, stealth no longer hides the Raptor. They speed towards the merge, roaring past each other at over Mach 1. Just like dogfighters of years past, these 21st century pilots turn into each other to initiate combat. Unlike previous generations, the F-22's onboard computer is actually monitoring how the maneuvering is stressing the aircraft.
If I'm asking the jet to do something, the computer decides that it would overstretch the airframe, it won't let me do it. And in an F-15, the jet will not prevent you from over-G the aircraft. The F-22 will prevent me from overstressing the airframe to ensure the long-term health of the airframe.
Finally, the F-22 gains lock and fires. The Rafale dives and brakes, releasing flares to draw off the missile. This engagement is over. But 3 miles away, another Raptor battle is just beginning. He's locked in a vicious circling fight with another Rafale. This F-22 pilot uses an advanced maneuvering technology called thrust vectoring to gain the advantage on his enemy. Thrust vectoring was originally developed in the 1960s for aircraft equipped with VTOL and STOL, or vertical takeoff and landing, and short takeoff and landing. Engineers quickly realized the benefits of the technology for tactical maneuvers.
Thrust vectoring is basically taking the exhaust out of the back of the engine and being able to steer it in a certain axis of flight. It's almost like a garden hose effect, if you will. If you turn the garden hose on full blast, that nozzle that the water's coming out of is going to push that hose around in a circle.
A handful of Generation 4 fighters, like the Su-30 and MiG-29, incorporated thrust vectoring. But not the American F-15C. The Air Force made up for this by perfecting the technology in the F-22 Raptor. As the Raptor turns, the aircraft's onboard computer makes tiny adjustments of the thrust nozzle to improve the turn radius of the aircraft.
Everybody talks about thrust vectoring as if there's some magic switch you push or something like that. There's not a light that comes on that says thrust vectoring's working. And so it's blended very smoothly. The pilot has no idea when it's moving. And so it's just effortless. The airplane flies and points and does what he wants it to do.
Thrust vectoring seamlessly allows the Raptor pilot to turn tighter circles while maintaining airspeed. Soon, he's in position on his enemy's tail. But suddenly, a second Rafale crashes the party. The enemy gains a feint lock on the F-22 and fires. A missile warning blares in the Raptor pilot's helmet.
If I'm looking back over my shoulder and I see a puff of smoke and a missile flying my way, there are certain evasive maneuvers that I will take as a fighter pilot to try and defeat that missile. It's a combination of maneuvering and chaff and flares.
The F-22 easily breaks the missile lock, but the maneuver has put him out of position. Now he must work with his fellow pilots to turn the tables.
The scenario where I'm in my fighter and I'm in a world of hurt and I need some help. My buddy, who I've been training and flying with for 5 years, that guy or that gal will stop at nothing to come and put their life on the line to save mine.
Voice communications between pilots are handled by the Raptor's integrated avionics system. The second Raptor quickly comes to the aid of his fellow pilot.
It takes years of training and being exposed to different scenarios and figuring out how you're going to handle those scenarios and still come away alive and having achieved your tactical objectives.
The first Raptor breaks hard into his opponent, forcing him in the direction of the second Raptor. The second Raptor locks on with his heat-seeking AIM-9X Sidewinder missile. The AIM-9X was approved for full-rate production in 2004 and should be fielded at any time. Many details are classified, but it is known that it will possess a type of thrust vectoring technology called jet vane control, which gives it much greater agility over its predecessors. The AIM-9X can also lock onto targets up to 60 degrees angled off its nose, known as an off-bore sight shot. The F-22 easily gains lock and fires. The Rafale is obliterated. But the first F-22's not out of the woods yet. Another enemy missile rockets toward him. He brakes, releasing flares. The missile lock is broken, but the enemy is still on his tail. He must do something drastic. The American will perform a dazzling maneuver called Pugachev's Cobra, named for a Russian test pilot who first performed it. He'll use thrust vectoring to force his tail down and his nose up. His airspeed will plummet, forcing the Rafale out in front of him. A move like this could easily get out of control for a Generation 4 aircraft equipped with thrust vectoring. But the Raptor's computer-aided flight systems will ensure the pilot stays in command. The Raptor pilot pops his nose up. His airspeed drops. The Rafale fights to stay in the turn, but has no chance. He shoots past the Raptor. The move demonstrates perfectly how pilots of the future will use technology to exert far greater control over their aircraft.
Everything he does is completely under control. He's controlling every motion. None of it's ballistic. He can stop those things at any point he wants and turn it around and go the other way.
The Raptor gains lock and fires a Sidewinder. The missile hits home. The rest of the enemy force flees south. The Raptors could pursue, but they choose not to. In air-to-air combat, the United States Air Force believes the F-22 will remain dominant for at least the next 20 years. It is unlikely that another country will develop a Generation 5 aircraft to challenge it anytime soon.
Why haven't they built them? Well, because it's hard. They're not easy to build. It takes very advanced companies, very advanced teams to put them together. It is attention to every detail.
The F-22 may have control of the air, but historically the greatest threat to a fighter pilot comes from the ground.
The greatest threat now to really any of our platforms is that very highly sophisticated and integrated air defense system.
Americans have already encountered integrated air defense systems over Bosnia and Iraq. An IADS can be implemented much more readily than a top-of-the-line Air Force, which requires billions of dollars and a top-tier pilot training program. An IADS, composed mainly of radar networks and surface-to-air missiles, have been the main line of defense in most Middle Eastern countries for decades.
Those are the systems that can find you, potentially, and track you and launch on you from 100 miles away. That is a pretty impressive brick wall that a country can put up if they don't want you to come into their territory. So you've got to find new ways to get up to that wall and knock the thing down.
In the future, these radar stations will be harder to find and destroy. Surface-to-air missiles will be longer range and more accurate. A strike mission against any country equipped with an advanced IADS will put the pilot of a Generation 5 fighter to the ultimate test. July 22nd, 2019. In a hypothetical combat scenario, a joint strike force of American and British planes soar over the Caspian Sea. On this night, a mission to strike suspected uranium enrichment sites will take them deep into a country fortified with an advanced integrated air defense system. At the tip of the spear will be a formation of 4 F-22s escorting 12 F-35 Lightnings, the Joint Strike Fighter. The F-35 began its development process in 1996. The design mandate called for a versatile aircraft that could smoothly move between ground attack and air superiority roles. The F-35 was meant to replace other strike aircraft like the F-15E, F-16, and F-18. It is hoped it will be the world's premier strike aircraft for the next 30 years.
The only airplane out there that the F-35 is going to have any trouble with, would even be parity with it, would be the Raptor. Nobody else will be close.
With a single powerful engine, the F-35 tops out at Mach 1.6, but it lacks supercruise and thrust vectoring. Still, it incorporates the same stealth characteristics as the F-22 and can be every bit as lethal in air-to-air combat.
F-35 is more optimized for both the air-to-air and air-to-ground kind of role that it's involved in. A little less maneuverable than an F-22, but certainly comparable to all the fourth-gen aircraft. It is a single-engine fighter, carries about 18,000 pounds of gas on it, so it will be able to fly at very, very significant ranges on a single engine.
In a future air war, the F-35 will perform a variety of functions, as opposed to the F-22, which is specialized for air-to-air combat. The F-35's airframe is easily and cheaply adapted for many types of missions. Variants are already being built.
One is an Air Force mission from fixed base. One is for the Marine Corps version from L-class carriers as well as austere basing. And the third is for the U.S. Navy, which lands on the large CV-class carriers. It's going to be a very, very interesting change to aerial combat when you have stealth fighters deployed from ships where the enemy really doesn't know where they are. So you think about a 600-mile radius based anywhere around the globe that's 70% water, really is a game-changing kind of aircraft.
The F-35 as well as the F-22 use an incredibly powerful radar called Active Electronically Scanned Array, or AESA radar. AESA is another key technological advantage that Generation 5 aircraft will have in a dogfight of the future.
It can stare at a very wide picture and give you a very good sense of what your targets are both on the air and in the ground. It's a very big improvement over previous radars, which were mechanically scanned, meaning that they had to move back and forth, and they did it much slower, and so the pilot didn't have as clear or as instantaneous as a picture as he would today with the newer AESA radar.
Looming before the strikers is a formidable electronic fortress. The IADS of the next 10 years will be incredibly lethal. Surface-to-air missiles will carry on-board radar, essentially becoming fire-and-forget weapons, unlike their predecessors, which were controlled from the ground. Radar systems will become smaller and more mobile, making them harder to locate and destroy.
So the first wave of an attack would probably involve your very stealthy vehicles. Why would you use these in the first wave? Because stealth, in essence, shrinks the view of the bad guy's air defense system.
The search and targeting radars in an IADS create a virtual picket fence. But the initial strike force of stealth attackers will slip through the gaps in that fence, positioned to destroy the defenses.
One of the things we want to do is create a corridor or a safe entry point and exit point for our strikers to go in and to deliver that desired weapon. One of the ways we'll do that is by taking down the enemy defenses systematically.
The F-35s and F-22s pierce the radar net undetected. But as the strike force steals in, another formation of friendly aircraft enters the area. Immediately, targeting radars across the IADS switch on. But the formation isn't what it appears to be. It's a diversionary force of 8 MQ-9 Reapers, unmanned combat aerial vehicles, or UCAVs.
Well, the unmanned combat air vehicles, the potential is virtually limitless. It's only limited by what kind of imagination we can apply to their capability.
Early UCAVs, like the MQ-1 Predator, were used to great effect in Iraq and Afghanistan. But a successor to the MQ-1 was already in the works. Operational versions of the MQ-9 Reaper were first delivered to the Air Force in 2007. The Reapers have a single prop engine in the back that can carry them up to 1,000 miles from their launch site at speeds of 300 miles per hour.
If nothing else, we know that one of the reasons people are intrigued in this technology is UCAVs, UAVs, they don't have mothers. So they are, in fact, not expendable, but able to mitigate risk.
If you don't have to put a pilot into danger to accomplish a mission, that's good. You can afford to lose the platform, perhaps. Yeah, they're expensive. You don't want to lose it. But if they really have to go into a high-threat environment, a vicious air defense system, yeah, let the drones go in.
For this reason, UCAVs will be an integral part of any future air campaign. The formation of MQ-9 Reapers trips the enemy's air defenses. Surface-to-air missile sites launch. A bevy of SA-23s race toward their targets at Mach 4. The SAMs easily track and destroy most of the decoy formation. But with radars active, their positions are plotted by the F-35s. The Lightnings snap into action. Aided by the same integrated avionics suite used in the F-22, they smoothly share targeting data.
And overall, this ability to send messages between the cockpits can't be underestimated, because when you look at your fourth generation fighters, you're in an F-16, you're always looking around you, where's my threat, and trying to build that picture all the time. Well, if you're in a Joint Strike Fighter, you have the ability to instant message your images between each other. So all of a sudden, you're looking at the exact same threat, and you both have the exact same concept of what kind of fight you're going to be in.
Two of the F-35s roll in to deliver AGM-88 harms against radar tracking stations. The harm, an anti-radiation missile, locks onto the station's radar signal and homes in for the kill. Two more F-35s fire on the SA-23 launch sites. Several other Lightnings, filling the electronic countermeasure role, jam other targeting radar stations to prevent further launches.
Another thing you can do with an ESA radar, and it's classified, is in essence fry the other guy's electronics. There's enough energy that you can focus with one of these radars that you can just cook his computer. Maybe you can knock out some of his radar system.
The F-35s have met with spectacular success, clearing a corridor for bombers to travel straight into the target. A pair of B-2 Spirits, the venerable stealth bomber, now enter the corridor on a final run-in. The F-35s maintain the corridor, but suddenly a new threat appears on their cockpit displays. They know their role must change quickly. The enemy has scrambled two separate formations of MiG-35 fighters. One is headed for the target area. The other moves in from the west. The Raptors can easily handle one formation. The Lightnings will be forced to deal with the second. The shadow boxing is over. The Lightning must now demonstrate that it isn't just a ground attack plane. It's a dogfighter as well. July 22nd, 2019. After devastating enemy surface-to-air missile sites, a flight of F-35 fighter bombers must now engage in air-to-air combat. 8 MiG-35s threaten the strike package from the west. The MiG-35 was first unveiled in 2007. The successor to the highly regarded MiG-29, the MiG-35 utilizes a thrust vectoring engine, AESA radar, and advanced avionics. Like the MiG-29, the Russian-built MiG-35 will be heavily marketed to foreign buyers. Although stealth aids the coalition forces, a pair of B-2 Spirits en route to the target area are still in danger. At close range, the enemy may be able to resolve even the low cross-section of a B-2.
Probably the most wonderful thing you could have as a MiG pilot would be to see a big, large black Dorito chip flying at 0.7 Mach at 35,000 feet over your homeland, and saddle up for a guns kill at 500 yards behind it.
Fortunately, the F-35s are up to the task of protecting the bombers.
It is a swing-roll aeroplane in the sense that it can do both air-to-air and air-to-ground at the same time. It was designed to be that from the outset. It's got a lot of thrust. It's got a very low wing loading. It's very easy to fly.
The F-35 pilots move into combat spread. careful not to engage the afterburner with its highly visible thermal trail. They seamlessly share targeting data and coordinate a long-range assault. Like the F-22, they are aided by an integrated avionics system that makes these tasks much easier than in previous generations of fighters.
It's a lot like going from an old DOS operating system on an IBM PC in the 80s to a Macintosh, Windows, very intuitive kind of environment now. We have examples where you take brand new second lieutenants out of the Air Force and drop them in the simulator, and they hop in, they see where the targets are, they engage them in 20 or 30 minutes, and they hop out with a grin on their face saying, yo, when can I get myself one of these?
On the flight lead's command, missiles are deployed, again, like the F-22 from internal weapons bays. The AMRAAMs race toward their targets. The MiG-35 use AESA radar to jam the missile's guidance. With hard maneuvering, they fight to break lock. But 3 are destroyed. The F-35s monitor the attack from a safe distance. But for one pilot, the situation has changed. A missile has jammed in the bay door. This hypothetical illustrates that even in planes of the future, Murphy's Law is at work. The malfunction disrupts the stealth outline of the Lightning. In moments, his position is betrayed to every radar station in the area. The surviving MiGs move in to intercept. Surface-to-air missile sites track his every move. This pilot will have to use every advantage the F-35 has to get home alive, including a remarkable technology that gives him an unprecedented view of the nighttime battlefield. The helmet-mounted display. The helmet-mounted display, or HMD, is a technological marvel. First developed for advanced Generation 4 fighters like the French Rafale and the Eurofighter Typhoon in the 1980s and 90s, HMD will soon be a fighter pilot's primary tool when in combat. An American HMD has been designed for use in the F-35 and will be standard on the Lightning when it is deployed to operational units in 2010.
I can't go into too much detail, but essentially in the F-35, the helmet-mounted display is the primary flight instrument. So here, the cockpit is very much designed to be secondary in some respects to the helmet.
While previous fighters displayed navigation and targeting information on LCD screens or heads-up displays, the HMD projects this information onto the pilot's visor.
So without looking down at anything, he can look around and scan and see where the enemies are, where his wingmen are, and begin to just select and engage them without looking down at anything.
The HMD integrates radar and infrared information to present a 360-degree view of the battlefield. With this, Lightning pilots can track opponents in any direction, even directly beneath the cockpit.
This is an advantage if you're in a situation where you can't turn your aircraft quickly enough to get your nose toward the target, but you want to hit that target. If you have a helmet-mounted display that can slave your weapons, then you're able to turn your head and shoot at that target before you even have a chance to get your nose on the target.
We'll slowly get a picture of what's happening on the air and on the ground as well. We'll pick our way through those defenses in the best way that we can.
Now, a lone F-35 pilot must use this incredible capability to beat the odds and make his way to safety. Projected on his HMD, he sees a missile launch warning. A MiG-35 has fired on him. The Lightning pilot first uses AESA radar to jam the missile. Previous generations of fighters needed completely separate jamming equipment. But AESA higher processing power allows it to track multiple targets and jam others all at the same time. The F-35's next move is to orient the top side of his aircraft to the missile. This part of the plane is still stealthy. The missile loses lock. Now he switches his display to night vision. Another task made very simple by the F-35's pilot-friendly interface.
On the F-35, it's an 8 by 20-inch piece of glass. There are no switches in the cockpit. It's finger on the glass, touch screen, very interactive in terms of being able to bring up a display, iconify display, make it big, make it small, depending on what the typical mission is.
The pilot spots a glowing burner plume. A MiG-35. The Lightning pilot slaves his missiles to the HMD. The missile's seeker head will now work to obtain lock on anything the pilot looks at. Just a glance, and the enemy's fate is sealed. But simultaneously, a SAM launch warning is projected onto the Lightning pilot's HMD. Again, he jams the missile and maneuvers against it. The HMD allows him to track the missile on its intercept course. But then another warning breaks the pilot's concentration. A nearby MiG has managed to launch a heat-seeking Archer 11 missile. The Russian-built Archer 11 has been the standard heat-seeking missile for MiG fighters since 1985. Continued upgrades will make the Archer 11 a threat long into the future.
These Archer 11 short-range missiles, which are supposed to be better than the AIM-9 Sidewinder, they don't get as confused by flares as, for example, the Sidewinder on the F-22.
The Lightning turns into the missile and deploys flares, but the Archer is equipped with an onboard computer that can distinguish infrared countermeasures from an aircraft engine. The F-35 is trapped, with a SAM in front and an Archer behind. To survive, he'll need the F-35's extreme maneuverability aided by its advanced fly-by-wire system.
Fly-by-wire was something that was introduced on fourth-generation aircraft. The F-16 was the pioneer of that technology. It was fly-by-wire from the pilot's stick to the computer, and then it went through a conventional hydraulic system out to the flight control surfaces.
But the F-35 goes one step further. The computer takes pilot inputs, then relays them to still more processors that control the flight surfaces individually.
So it's very, very maneuverable, and it has to be, but very, very benign in situations like landing on a carrier or landing in a STOVL kind of configuration.
As the SAM closes in, he rolls, punching chaff and flares. The Archer missile hesitates for a moment, then detonates, blasting shrapnel directly into the SAM's path. The Lightning streaks north, now safe within the SAM-free corridor he and his fellow pilots blasted away earlier in the night. He's informed that the rest of the MiG-35s have all been shot down, and the B-2s have successfully reached the target. The mission is accomplished, but the pilot's brief experience in an unstealthy F-35 is a stark reminder of just how vital the technology is. For an Air Force built on it, a scenario in which the stealth advantage is negated will quickly become a nightmare. April 8th, 2027. In a hypothetical future combat scenario based on known diagnostics, A formation of 8 French-built Rafales flies a patrol over the Pacific Ocean. A flight of 4 American F-22 Raptors accompany them. Even 20 years into the future, this remarkable aircraft is expected to remain the dominant air superiority fighter.
I would say, based on all of the things I've read and all the things I've heard, we are at least a couple decades away from having to really face a significant or a viable 5th generation threat. When that technology finally catches up to where the United States is today, guess what? The Raptor is going to evolve. The Raptor 2 decades from now, that some kid's going to be flying and I'm going to be sitting at my desk, is going to be nothing like the Raptor that's flying right now. It would kick the snot out of the Raptor today.
Although most of these upgrades are top secret, one is assured. By 2011, the U.S. military expects to add a helmet-mounted display to the Raptor's arsenal of high technology. At 10:42 a.m. local time, the Raptors detect an ominous signal on long-range radar. A flight of 18 Su-30s. An aircraft not flown by any allied nation. The enemy formation appears on the Raptor pilot's HMD. The Americans monitor their progress, relaying instructions to the unstealthy Rafales. At a range of 25 miles, the Su-30s fire on the Rafales. A salvo of long-range radar-guided missiles. They streak towards their target, covering 1 mile every 2 seconds. The Raptors' rules of engagement prevent them from intervening. They are forced to watch from the sidelines as 2 Rafales are destroyed. The rest retreat, unable to stand and fight in the face of 5-to-1 odds. Just then, the Americans are cleared to engage the MiG-35s in a novel way. The lead Raptor data links the coordinates of one of the enemy fighters to a 767 with a circular turret on its nose. The nodule contains a high-energy solid-state laser capable of vaporizing an enemy aircraft from a range of 90 miles.
The aircraft is a platform for whatever weapon you want to put on it. We started off with a gun, we went to some rockets, then we went to guided missiles. And if a beam-type weapon, a directed energy weapon, is the next step, then it's logical to expect that we'll put that on as well.
It sounds like science fiction, but defense contractors are already at work on weaponized lasers. The concept dates back to the 1980s and the Reagan administration's Strategic Defense Initiative, nicknamed Star Wars. These lasers were meant to target and destroy Soviet ICBMs. In recent years, this knowledge has been applied to the development of the airborne laser, or ABL.
It's just a very large laser that's mounted in a Boeing 747 type aircraft, and it has the system such that it can acquire a target, primarily a missile, but it could be a fighter, and then fire a very powerful laser beam at that target and take it down.
The ABL of today are bulky chemical oxygen iodine lasers designed as anti-ballistic missile weapons. Boeing and Northrop Grumman hope the first operational test of this ABL will occur in 2009. If successful, engineers will continue work on the ABL as well as other applications of high-energy weapons. It is hoped these lasers can be mounted on multiple platforms, aircraft, ships, even tanks.
Pretty soon, we are going to have those weapons. And eventually, the first time they find out we're using them tactically is when they start disappearing off the screen and we haven't fired a shot as far as being a fighter jet.
When such weapons reach the field, air combat will again be revolutionized. All a pilot will need is a coordinate, and with the press of a button, destruction at the speed of light. The Boeing, safely out of missile range 150 miles away, charges the laser and fires. The beam is in the infrared spectrum and is not visible to the naked eye. One of the lead Su-30s is vaporized. The effect of the weapon is slow to sink in for the enemy formation. No one is quite sure what happened. A second coordinate is relayed to the 767. Again, the laser fires. Now the Su-30s take evasive action, diving toward the Pacific to flee the lethal ray. With open war at hand, the Raptors secure permission to engage any hostile target. Then, the Raptors' missile alarm rings out. Despite their stealth, the F-22s are being actively tracked by several Mach 5 surface-to-air missiles. In an instant, the era of stealth has ended. April 8th, 2027. In a hypothetical combat scenario based on what military experts believe the future of air combat will be, a flight of 4 American F-22 Raptors have come under attack. A salvo of surface-to-air missiles are tracking. They've locked onto the stealthy F-22s using low-frequency radar, a vulnerability of stealth technology exploited by the Serbs in Kosovo in 1999. During this conflict, an F-117 Nighthawk was lost to a surface-to-air missile that was modified to use low-frequency radar to lock onto targets. The drawback of this type of radar is the huge amount of clutter it detects. This is why no one else has been able to duplicate the feat.
Though they say that low-frequency radar could possibly see stealth aircraft if it was computer-aided and they were able to clean up all the clutter and then actually focus in on a stealth aircraft. To say that's a viable option, sure, possibly. With the amount of computer power we have these days, that could possibly happen. But you still have to know exactly where in the sky to look for a stealth airplane.
The Raptor pilots take immediate evasive action. These SAMs are traveling at an astonishing speed, over 2,000 miles per hour. The pilots cannot rely on their eyes. The missile is simply moving too fast. The HMD aids them, projecting the SAM's position on the visor so they can maneuver. One missile finds its mark. Hurling deadly shrapnel into the air like firing a shotgun the size of a telephone pole directly into the Raptor. The American is forced to punch out. With quick thinking and aggressive maneuvering, the 3 remaining F-22s defeat their missiles and retreat. But as they withdraw, another warning blares. They've been fired on again. This time, radar-guided air-to-air missiles, seemingly launched out of the clear blue sky. This adversary seems to have Generation 5 technology.
I think the first time we face a Gen 5 fighter as the United States, it's going to be a surprise. We're probably not going to know they have it.
The Raptors scramble to defeat the missiles. Then they pick up several faint radar contacts. Enemy aircraft moving towards them at Mach 2. The Raptors move into full afterburner and speed towards the merge. Efforts to gain a lock for an AMRAAM shot fail. Moments before they reach visual range, AWACS confirms the identities of the mystery planes, Russian-designed Sukhoi Su-47s. The Su-47 was introduced in 2000 and is only at the beginning of its development. But the Russians hope this will be the first Generation 5 aircraft built outside the United States.
They have the technology, it's just a matter of them getting the money and the wherewithal to put it together, and the threat. Right now, I mean, they're not threatened by us, they're not doing anything to us. There are other countries out there that are threatened by us, and they do have the money. So sure, are they going to probably get some stuff from Russia? Probably.
The Sukhoi, top speed over 1,500 miles per hour, has a unique forward-swept wing, giving it greater agility in a dogfight. With thrust vectoring, advanced avionics, and AESA radar, the Su-47 will be a formidable adversary.
We will already have a game plan to do battle with that type of fighter. And we have that already because there's Raptors fighting Raptors. So they're already developing techniques and tactics against other Gen 5 fighters.
The Raptors and Sukhois fire radar-guided missiles at long range, testing each other out. Their AESA radars easily jam the missiles, and a few simple maneuvers break lock. In this scenario, technology is a virtual wash. It's pilot versus pilot. One unlucky Raptor pilot attracts the attention of 3 Sukhois.
No matter how high-tech the aircraft get, we are going to need to keep developing our dogfighting skills, because there can come that situation where you do get stuck in a phone booth with somebody, and if you don't dispatch with them quickly, the 4 or 5 other guys coming up at you will eventually get you.
The Su-47s engage the F-22 at close range, firing heat-seeking missiles. The enemy pilots contain the fiercely maneuvering American F-22. Despite their best efforts, they can't knock the Raptor out.
The West way of fighting is you allow the individual to assess the situation on site, and then he makes the determination, or she makes the determination that this is the way I'm going to fight this battle.
The American uses the F-22's spectacular maneuverability in close to gain position for a shot. In an instant, he swivels his head up. A Sukhoi's glowing red tailpipe blazes 50 degrees off his nose. His sidewinder locks. The missile streaks in. Its continuous rod warhead, a packed ring of welded steel rods, bursts open inside the aircraft.
That's why we are training our people to do air-to-air combat as well as air-to-ground, and not just beyond visual range air-to-air combat. We're still teaching basic fighter maneuvers, how to handle the close-in fight.
The Raptor quickly rolls and turns. The Sidewinder shot has improved the odds, but a quick check reveals he's now in a dangerous position, sandwiched between the 2 remaining Sukhois. Quickly, the American formulates a plan, one that harkens back to the golden age of dogfighting.
In the event the worst case happens, and you do get into close quarter combat, you still want to have the ability to fight your way out with a gun.
The Raptor is equipped with a single Vulcan rotary cannon, mounted in the starboard wing root with 480 rounds of ammunition, strictly for close encounters.
The gun in the Raptor is really designed to be an air-to-air weapon. The gun is an effective weapon. With some of the new bullets, the ranges go up quite a ways.
Past generations of fighters have made the mistake of not carrying a gun. Most notably the F-4 Phantom. When it took to the skies over Vietnam in the 1960s, it was roundly criticized by pilots. Missiles of the time were unreliable, and without a gun, pilots had no backup. Since then, air superiority fighters have always had a gun. Using his HMD, the American looks through the floor of his F-22, tracking the movements of the enemy beneath him. He rolls inverted, then gains lock, using his AIM-9X's ability to track targets at any angle. As the missile streaks away, he deftly adjusts the nose, firing a well-aimed burst just before blacking out. He comes to just in time to see the missile impact the first Sukhoi. Now alone, the American tries to re-establish contact with his fellow pilots. One other has survived the lopsided battle. 2 Raptors were lost in the engagement. The enemy, badly mauled, is in open retreat. The Raptors form up and head east. But as they retreat to safety, garbled transmissions begin trickling in. Command and control has clearly taken a hit. Then the Americans receive shocking news. In the opening moments of the war, a score of military and commercial satellites have been blinded. The battle has moved to space. April 8th, 2027. War has broken out over the Pacific. In the opening moments, anti-satellite weapons are deployed aboard missiles launched from the surface. The final stage of the rocket carries a kinetic so-called hit-to-kill vehicle to a devastating collision with an American military satellite. The hit-to-kill concept is purposefully simple, since the kinetic energy of an object traveling 7 miles per second is more than enough to destroy a satellite. There is no need for more complex and expensive explosive warheads. American forces engaged in the fight are crippled.
We are very satellite dependent. GPS is very important to almost everything we do tactically, to developing a big picture, to transmitting information back and forth from our command and control circuits. You've got a nation that wants to use anti-satellite technology to knock out that capability.
Just talking in the military sense, we do rely on the spaceborne platforms for a lot of information: intelligence, surveillance, reconnaissance, communications, missile warning, navigation, and even weather.
At present, no government publicly acknowledges the development of space weapons. But in February 2008, as a test, the U.S. shot down one of its own aging spy satellites. Seen here in the actual footage, a modified anti-aircraft missile was launched from a ship. The collision was designed to destroy the satellite's fuel tank, full of toxic hydrazine. Upon impact, an explosion. The gathering vapor cloud indicated the mission was successful. This test was performed in response to a similar feat by the Chinese in 2007. To defense experts, this points to a clear desire to potentially project military power into space.
Going clear back to winning the West days, the cavalry really wanted that high hill for observation purposes. Well, for many decades now, space has been the high ground.
If you are an adversary knowing that that has become such a strength, maybe a dependency, therefore maybe a vulnerability, it is very possible, it's not unreasonable, to think that an adversary might use space as a medium for denial as well.
But satellites could also be disabled without destroying them. Powerful ground-based lasers could be employed, targeting the satellite's optics.
Our satellites have experienced something they call dazzling. So lasers fired from the Earth into optical systems on our satellites can temporarily blind them or blind them permanently if they hit the right sensor in the optical system to where you burn it out or you just flash blind it.
Just then, the Americans detect a fast-moving vehicle skipping through the upper atmosphere at Mach 18, 9 times faster than anything in the air today. They quickly identify the threat, a Russian-built scramjet, a hypersonic space plane capable of flying the length of the continental United States in 20 minutes. Luckily, the Americans have been working on similar technology and dispatched their own scramjet to intercept the enemy.
The history of air combat has always been measure, countermeasure. As soon as somebody develops a capability, somebody else will develop the counter capability to that.
Since the 1970s, spaceplane technology has been viewed as a possible method of hypersonic travel at speeds in excess of 3,000 miles per hour. This concept was made famous by the Rockwell X-30 in 1986, seen here in animation produced at the time. President Ronald Reagan heralded an era in which spaceplanes would ferry passengers from New York to Tokyo in 2 hours. But the X-30 never made it off the drawing board. The program was canceled in 1993 due to budget cuts. The X-30's scramjet propulsion system, however, has not gone away. The Air Force is currently experimenting with the X-51. A vehicle meant to simply test the functionality of a scramjet engine, or supersonic combustion ramjet. The engine itself is a simple power plant with no moving parts that harnesses the high pressure of air entering the intakes at supersonic speed. The compressed air is mixed with fuel and ignited to create very high propulsive thrust.
The day may come when you can use that sort of engine to get us up into the very high reaches of the atmosphere and then perhaps into space. The big kicker is once you get into space, you have to have your own oxygen in order to burn something in space because there's just nothing up there to do that.
The projected speed potential of scramjet-powered craft is thought to be near Mach 25, an astonishing 20,000 miles per hour. 10 times that of the fastest conventional jet aircraft in history, the SR-71. With this technology, spaceplanes could take off from bases in the U.S., lift into low Earth orbit, and strike targets anywhere in the world within 3 hours.
Performance is the name of the game. We want speed, we want the ability to reduce the time to react. The scramjet technology gives us that ability. To be able to skip off the atmosphere and go around the world quickly, that's also an advantage.
Both spacecraft accelerate, slipping free of Earth's atmosphere into orbit 100 miles above the surface. The American maneuvers within range of the enemy scramjet. Since conventional missiles are useless in the vacuum of space, the only armament the scramjets carry are beam weapons, high-energy lasers similar to those currently being researched for missile defense. The stage has been set. For the first time in history, 2 pilots will duel to the death at the very edge of space. In the year 2027, Two scramjets are about to square off in the first dogfight to take place outside of Earth's atmosphere.
What happens if we go on out into space? Then we're into a whole new realm. What does that mean in terms of fighters? Well, if you're going to have two space planes duking it out in Earth orbit, we have to change a lot of things because physics rules out there no different than it does in the atmosphere.
Tactics instinctive to pilots for nearly a century are suddenly obsolete. Orbital mechanics, not aerodynamics, govern the maneuvers.
The way you can think about being in orbit is a rock on the end of a string. Because you move the rock fast enough, the string stays taut and the rock stays out there. If you quit swinging, the rock falls then. The same thing happens to a spacecraft. That if it slows down, it falls towards the Earth. The only way it stays in orbit is to maintain a minimum speed. If it speeds up, it'll go to a higher orbit.
The American scramjet carefully maneuvers closer to his adversary. The jockeying for position in orbit is slow and deliberate, a far cry from the turn and burn dogfights of the first 100 years of aviation. But the results will be just as lethal. The Americans' only weapon is a high-energy laser, the most plausible weapon for a space plane to use. Recoil from conventional weapons like guns or missiles would drastically affect the scramjet's position in orbit. The American finally positions himself for a shot. The laser charges. He fires. The invisible beam arcs out, boring through the enemy scramjet's engine. The laser is not strong enough to burn through its tough outer hull, but it doesn't need to. As the scramjet decelerates, he drops into the atmosphere. The friction of re-entry superheats the aircraft. The tiny surface damage near the scramjet's engine cracks and opens. Soon, the entire vehicle breaks apart. For the American, victory is bittersweet. As he watches his enemy burn up in the atmosphere, the frightening implications of warfare in the future are all too real. From here to the very edge of space, to the traditional dogfight taking place in Earth's atmosphere, the nature of air combat has changed.
The air combat situation doesn't become less complex, it becomes more complex. Now you have more variables. So you ask how it'll change, it'll be everything they've done in the past and more.
The dogfight was forged above the trenches of World War I, when pilots first stepped into canvas and wire biplanes and took to the air. Its golden age came 30 years later, when incredible, powerful piston-driven fighters clashed over Europe and the Pacific. In Korea and Vietnam, jets drove dogfighting faster and higher, and guided missiles opened a new world of tactics. The modern age of air combat has seen astonishing leaps in technology. And there is no reason to think this progress will be slow. But in battles waged higher and faster, in ever more complex machines. The courage and savvy of the fighter pilot is one thing that will never become obsolete.
Regardless of the degree of autonomy, regardless of the degree of sophistication in networks and architectures, a pilot is still a pilot.
There will always be a need to fly aircraft aggressively and capably against other aircraft. And there will be dogfights in the future. It's guaranteed. Exactly how long they will last, who they'll be with, what the outcomes will be, those are all up to the participants. And the pilots of the future may not look and may not think exactly the way I did, but they will adapt. I am very confident.